Microservices confused me for years. Until I actually built one. And once I did, everything clicked. In this complete guide, I'll show you exactly what microservices are, when to use them, how to build two real services from scratch, make them talk to each other, add an API gateway, set up separate databases, wire everything with Docker Compose, and get production ready. Beginner to intermediate. Let's build it. Section 1. What are microservices? In plain English, a monolith is one big application that does everything. Users, orders, products, payments all in one project, one database, one deployment. Change anything and you redeploy the whole thing. Microservices split that apart. Each service is a small, independent application that owns exactly one business domain. A user service only handles users. An order service only handles orders. They each have their own database and their own deployment. Change the user service? Deploy only the user service. Everything else keeps running. Section 2. When should you use microservices? Honest answer, probably not yet. Microservices add real complexity, more projects to manage, more network calls to debug, more infrastructure to maintain. Always start with a monolith. Switch to microservices when your team grows past 8 developers, when different parts of the system need to scale very differently, or when teams need to deploy independently without coordinating. Never use microservices for a side project or when your domain boundaries are still fuzzy. The golden rule: start with a monolith and extract services only when you feel the pain. Section 3. Solution structure. We'll use one .NET solution file with multiple web API projects inside it. This keeps everything in one repository while keeping services independent. Create a services folder with user service and order service. Each is its own ASP.NET Core Web API project on its own port. Create a gateway folder for the API gateway. Create a shared folder for DTOs that services send to clients. Important, the shared project contains only data transfer objects, no business logic, no database access. Services do not share code beyond these simple contracts. Section 4. Building the user service from scratch. Run .NET New Web API with the name user service. Add Entity Framework Core with the in-memory provider for now, we'll switch to a real database later. Create a user model with ID, name, and email. Create a user DB context. In program.cs, use minimal APIs to define your endpoints. Get/API/users returns all users. Get/API/users/ID returns one user. Post/API/users creates a new one. The service runs independently on port 5001. That's your first microservice done. Section 5. Building the order service. Same process. .NET New Web API, name it order service. But here's the critical design decision: the order model stores a user ID integer, not a full user object. This is database per service isolation. Order service never touches user service's database. It doesn't have a navigation property to user. It stores only the user ID as a foreign key by convention. If you need the user's name in an order response, you call the user service API, not its database. The order service runs on port 5002, completely independently of the user service. Section 6. Making services talk to each other. When order service needs user information, it calls user service over HTTP. Register a typed HTTP client in dependency injection with the base address pointing to user service. Create a user service client class that wraps the HTTP client. It has one method, getUserAsync, that calls get/API/users/ID and deserializes the response. In your order endpoint, inject user service client and call it to enrich the order response with the user's name. This is synchronous HTTP communication, simple, easy to debug, and appropriate for most scenarios. Section 7. API Gateway with YARP. Right now clients need to know port 5001 for users and port 5002 for orders. That's a problem. An API gateway gives clients one single URL and routes requests to the right service behind the scenes. YARP stands for yet another reverse proxy, and it's built by Microsoft specifically for .NET. Install the yarp.reverse proxy NuGet package. In program.cs, add 3 lines, add reverse proxy, load from config, and map reverse proxy. In appsettings.json, define your routes. /API/users goes to the user cluster at localhost 5001. /API/orders goes to the order cluster at localhost 5002. Clients only ever talk to port 5000. Section 8. Database per service. This is the most important rule in microservices. Each service must have its own database. Never share a database between services. When services share a database, one team's migration can break another service. One slow query from one service can bring down the other. You lose all independence. The correct approach: user service uses users.db, order service uses orders.db. Completely separate. If order service needs user data, it calls the user service API. It never connects directly to the user's database. Switch from in-memory to SQLite or Postgres per service when ready for production. Section 9. Docker Compose for local development. Running 3 services manually on 3 different ports gets painful fast. Docker Compose solves this with one YAML file and one command. Create a Docker file for each service using the multi-stage pattern. Then create a docker compose.yml at the solution root. Define user service, order service, and API gateway as services. Set the ports, environment variables, and depends_on relationships. The order service gets the user service URL as an environment variable, the service name in Docker Compose is the host name. Run docker compose up -- build and all 3 services start together, networked automatically. Section 10. Production readiness. Before you ship microservices to production, add 3 things. First, health check endpoints on every service using add health checks. Map them to /health. Your infrastructure needs to check these to know when to restart a crashed service. Second, resilience with Poly. Add standard resilience handler to every HTTP client. This gives you automatic retries with exponential backoff and a circuit breaker that stops calling a service that's down. Third, replace in-memory with real databases, Postgres or SQL Server. Update your connection strings per environment. Add a correlation ID middleware to tag every log with the request trace so you can follow requests across services. And that's microservices from scratch, beginner to intermediate. You built 2 real services, made them communicate, added an API gateway with YARP, enforced database per service isolation, wired everything with Docker Compose, and got production ready with health checks in Poly. Microservices are not magic, they're a tool. Use them when the problem fits. Start with the monolith. Extract when painful. If this guide helped you understand microservices, smash the like button and subscribe for more .NET and architecture content. Drop a comment: what microservice will you build first? See you in the next one.